Hello students. So today we are going to start a new chapter. Okay. So chapter number 5, and it is multi-degree of freedom. Degree of freedom. Okay. So this is in the paperback. The chapter will be written as a multi-degree of freedom vibration. However, in the ebook, it will be 2-degree of freedom system. So, of course, 2-degree of freedom system, you can extend it to any number of degrees of freedom system. Okay, so although we will the chapter name is multi-degree of freedom system, but most of our talks will be confined to 2-degree of freedom system, and that we will see how that can be extended to any number of degrees of freedom system. Okay, so this chapter is basically it will follow the same pattern as we have done earlier for single degree of freedom system. That is, we looked at the free vibration of the system, for example. Then we had the forced vibration of that, and then transient vibration. So similar pattern we will have. You understand now what is the difference between the 3 types of vibrations. Here, only difference here from earlier lectures is, instead of we having 1 degree of freedom system, meaning that a system something like this one, where you had KCM and there was only one variable X, we have now different variable, more than one variable, what I mean. So it could be something like M1, K1, C1, then K2, then C2, this M2, right? And so on. So here you see X1 and X2. This mass M1 can be anywhere, and X2 also can be anywhere, and they are independently can be like that. So the idea is to actually find out, at least study how this system behaves, how it is different from this one, and what are the important things. Is there any new concept in this case that we will see? Of course, to begin with, we will start with the undamped system. So undamped system. Yeah, that really means what we are going to study first. So look at just a spring mass system only. So let us say our system is something like this one, and then we want to see how this system behaves. The system could be many kinds, not only this, maybe there may be like this also, one mass here and like this, and so on. This also 2 degree of freedom, because 2 masses, there will be X1 here, X2 here, or many more. We can also have 3 degree of freedom system. So right, have like this, then have like this mass here. So M1, M2, M3, and then you have K1, K2, K3, and so on. So the idea is, if you know how to solve this one, you can solve all this very easily. We need to know how the multi-degree of freedom system works, because whatever we learn for single degree of freedom, we cannot directly, is not directly applicable here. Not all the things. Yeah, the ideas are similar, the equations will be similar. However, what we will see here, this will be a matrix form here. There will be linear equations, but not one equation, but number of equations. So 2 degree of freedom system will have 2 equations, for example. In this case, 1 degree of freedom system, only one equation. So when you have more than one equation, then it will work differently. So that's what we will see today. So a few key concepts we need to understand. For that, let's start with the most basic multi-degree of freedom system. And what we have is K1 here, M1, we have X1, K2, M2, and then we have X2. Okay, so this one, the basic thing, you would always start with the equation of equilibrium. Okay, however, let me start with just understanding, just looking at the system. We want to guess how the motion of this system look like. Okay, based on that, we can actually think in that direction how to solve it. Okay, now if we try to guess what kind of vibration it will have, again we are talking about the free vibration right now. Okay, so free vibration. Okay, free vibration of multi-degree of freedom system. In this is particularly 2-degree of freedom system. So what do we expect? In case of a single degree of freedom system, what you expected is you gave little bit of disturbance and it will just oscillate up and down. That's it. In this case, we have two masses. Of course, this is going to oscillate up and down. Both will go up and down. But the question is, how will it look like? Particularly, what we are interested to find out whether both the mass will come down simultaneously and then go up. Means both will be either going up together or coming down together, or will there be mass 1 coming down while the mass 2 going up, and then when mass 1 goes up, mass 2 comes down. So what kind of behavior will it show? That's the question. And also, like in this case we had a fundamental frequency. If you give some disturbance, what you will see is with some frequency, this will be oscillating. In this case, what will be the frequency of oscillation? Now what is the meaning of frequency in this case? Here it was only one mass, we can understand. Here, is there only one natural frequency here or more than one? If more than one, what is the meaning? If one, what is the meaning? Is that the oscillation of mass which has that frequency, mass 1, or is that for mass 2, or combined? If combined, what is the meaning? All those things are the thing we need to understand, and we will be understanding today. Okay, let's guess the answer. But for me it is, I know the answer. Okay, but still, let's call it, we are guessing this answer, and based on that we can propose the solution and we will get the details of the solution. Okay, so we will say that there may be two kinds of solution. Okay, the general solution will be of two kinds. One will be something like K1, M1, when M1 goes down, M2 also goes down. Okay, and the second will be K1 when M1 goes down, M2 goes up. Okay, well, the solution will be a combination of the two. That's what we will see, right? Either combination, either it will be this or that, or a combination. Okay. Solution in real life, the solution will be something like this. Both will go together, up, down, or is going like one down, one up, goes like this. Or in real life, there will be a mixture of the two. Some this, some of that. Okay. If that is the case, how will the solution look like? Okay. If it goes like this one, most likely there will be a relationship between x1 and x2. Okay, so this is the x1, this is x2. There will be some relationship between x1 and x2. Here also there will be relationship between x1 and 2. And here will be x1 will be a multiple of x2. So it will be something like x2 equal to alpha x1, let's call like that. Right? Okay. Or we call x2 over x1 equal to alpha. In this case, x1 and x2, here x1, this is x2. Again, x2 will be minus beta x1, or x2 minus x1 equal to minus beta, where alpha, beta both greater than 0. Means positive, both are positive. That's what I mean to say. These are the solutions that we will get. We will come back, we will actually solve them, but you try to understand first what we are expecting, okay? And accordingly you can appreciate the solution. So the solution will be a combination of two modes. We call it modes, okay? So this is mode 1, okay? This is mode 2, okay? Now, so understanding the frequency in terms of that, natural frequency, if it goes down, up, down, up, now natural frequency of this will be the combined system of M1 and M2, how it completes one cycle. This will be omega 1, omega n1, or call it omega 1, natural frequency. There will be natural frequency omega 2, which is associated with mode 2. Means how fast this system, when one goes up, the other goes down, how fast this system is, means how many cycles per second of this kind of vibration is. So the natural frequency associated with this mode is omega 2. Okay. So what we see, we are expecting there will be two natural frequencies, one associated with this mode and another associated with this mode. One associated with mode when both of them goes down, either go down or go up. The mode 2 is when one goes down, the other goes up, when one goes up, the other goes down, like this system. Yeah? Both of them may not have the same natural frequency. Okay. So mixture, if somebody tells you what will be the solution will look like, solution for this one, just for this mode, we are guessing will be something like this. x1, x2. Since this is both will be, you have to write together because both are related. x2 over x1 is related by, right? So we have to write something like it will be if x1 is 1, x2 is alpha, so 1 alpha, and then you can sine omega 1t. This could be the most basic. You can also have C1 here, let's call it C1. Okay, so there will be a constant C1 which associates amplitude may vary. So C1 multiplied by 1 alpha, which is a vector, sine omega t. So x1 is equal to C1 sine omega 1t, x2 equal to C1 alpha sine omega 1t. This is one solution, which will be the which will represent this mode. Okay, how x1, x2 will be. For this one, what we are expecting is x1, x2 will look like something like C2, and then it will be x1 is 1, x2 is minus beta, like this one, and then we have sine omega 2t. We are expecting the other solution like this one. The final solution will be, if you combine them together, will be simply x1 plus x2 equal to C1, right? So C1 1 alpha sine omega 1t plus C2 1 minus beta sine omega 2t, right, x1, x2. This will be the combination, okay. So final form of the solution for this system will be a combination of these two. And what we have? We have variables. Which one? C1, alpha, C2, beta are to be determined. And how do you determine? In case of 1 degree of freedom system, you had to give the initial values, right? Initial values at t equal to 0, what is x1, what is x2, what is v1, what is v2, right? So that's what we have to give here. So in a 1 degree of freedom system, you have at t equal to 0, what is x, and at t equal to 0, what is x dot, means what is the velocity, what is the position. In this case also, we need to find out, in order to find out this one, we need to know what is x1 0 equal to what, x1 dot 0 equal to what, x2 dot 0 equal to what, x1 0 equal to what, and x2 0 equal to what. So there are 4 equations that you get from here, and there are 4 variables here, and you can find out C1 alpha, C2 beta from there. Okay, now that's fine. We can find out what is alpha 1 and alpha 2. That we have to find out. So basically, we have to do the analysis to find out all these values. Okay, and that's what we will do. We will do the analysis to actually find out the value. We will see this also, how much this is applicable, whether we need all of them, or for example, in order to find out alpha and beta, this is the way we are going to find out, or we can find out some other way. Okay, so that we will see. Okay, so but finally we have to solve some equation of equilibrium, and then only we are going to find all those values. Okay, so that's what we will do now. Okay, so the concept of the solution will make you understand why we will proceed the way we are going to. So let's start with the same 2 degree of freedom system that we have considered. So K1, M1 is as x1, and then this is K2, this is M2, and this is x2. Always we have to start with the equation of equilibrium. Yeah. So what will be the equation in this case? Okay. Equation will be, in order to find out, always draw the free body diagram. So free body diagram of M1. Okay. As I said earlier, in order to find out the solution, find out the equation, you have to first have the free body diagram, and in that, so that you don't confuse with the sign, always we can assume something to be a small rather than some. For example, you can assume that x2 is bigger than x1 is bigger than x2. So this is just, you don't need, basically this is my way of understanding, my way of not getting confused. So we can assume what? We can assume x1 is bigger than x2. Yeah? Or you can even say x2 is very close to 0 also. So that even you can check whether what we are doing is making sense or not. Yeah? Okay. So now, what happens in this case? M1, x2 is very small, and x1 is, yeah, so you can say equal to 0. Yeah, like this. Okay, so that really means x2 is right there wherever it is, and x1 has moved. Okay, and then if x1 is moved down, K1 will stretch and hence the force go up. And this will be K1 x1. Same here, x1 has come down and x2 has not moved, and it has moved very little. Okay, you can say not close. It's actually the force will be equal to K2 x1 minus x2. Yeah. So why x1 minus x2? This is because we are assuming x1 is bigger than x2, hence x1, since x1 is bigger than x2, it is going to compress the spring. If the spring compresses, it is going to resist the motion of this, right? So because it is compressed, the force will be upward, and hence this is K2. Or in any case, if you have a spring here, a mass here, a spring here, and if you move down, this will also resist, and then this will also resist, because this will compress, this will be under tension. So both of them will actually apply the force, resistive force. Okay, so the value will be K2 times x1 minus x2. Okay, done. And the x1 double dot is the acceleration here. Hence, the equation of motion is summation of forces equal to m1 x1 double dot. That's what it will be for this one. And forces are all negative. So K1 x1 minus K2 x1 minus x2 equal to m1 x1 double dot, and hence you get m1 x1 double dot plus K1 x1 plus K2 x2, okay, minus K2 x2. Sorry, here it will be K2 x1 minus K2 x2. So all of them go that side, and hence you have that equal to 0. This is true for mass 1. What about mass 2? So for mass 2, we can draw similar cuboid diagram which looks like this one. So we have M2, and what do you see here? Now what you have assumed, you can re-assume the way you want, or you can assume like that. What you are saying? You are saying in this case is x1 is bigger than x2. If x1 is bigger than x2, then this will be a compression. Compression will be how much? X1 minus x2. And because it is compression, the force will be downward. And what will be the value of force? Value of force will be exactly like this one. Direction will be different because these represent the two ends of the spring. At one end it will be upward, the other end should be downward, and value should be the same. So it should be K2 x1 minus x2. That's it. And here we have to write again the force equal to, again in this case we have x2 double dot, force, total force is equal to m2 x2 double dot, and hence what do we get? We get K2 x1 minus x2 equal to m2 x2 double dot. Yeah, and hence we get m2 x2 double dot plus K2 x2 minus K2 x1 equal to 0. So we get this one as equation number 2, and we have this as equation number 1. So these are the two equations. Yeah, and what you see here, it is the equation is coupled, meaning that it has x1 and x2 both. This also has x1 and x2 both. So we cannot solve independently. We have to solve them together. Solve them together means we have to apply the linear algebra. Okay, we have to apply the matrix, the algebra that you have studied. Yeah. Okay. So let's have this equation here. So first equation we can write in the matrix form. What we are going to do is we can the same equation whatever we got here, I will write in matrix form here. Okay, so the first equation and second equation both we are combining together. As I said, since it has two equations and we have to solve simultaneously because both are coupled and both are linear equation, hence we can apply the linear algebra or matrix algebra that you have studied. And how we are going to write? We will write like this one. So M1 0 0 M2 and we have x1 double dot x2 double dot, okay, plus. So we got M1 and M2 covered here. Now next is we have this mass matrix, then a stiffness matrix will come into picture. So we have something here and we will have x1 here and x2 here like this. Okay, will be equal to 0 0. So that's what we are going to write. What will be the value here? So see here, whatever is the coefficient of x1, the x1 has k1 and k2. So we write here k1 plus k2, and this x2 has minus k2. So we have minus k2. Come here. So this one is x1 has minus k2. In this case also we have minus k2. So we write minus k2, and here x2 we have k2. So we have k2 like this. Okay. So this is the equation we got, M1, M2, this is the mass matrix, this is the stiffness matrix. So we got k1 here and then k2 minus k2 minus k2 k2, then x1 x2, total equal to 0. Okay. So this is the equation which needs to be solved, and now we can guess. Also, the origin of the kind of guess we are going to do, you should have done already during your mathematics class, during the matrices or linear algebra class. Okay, and also you can extend the solution of single degree of freedom system to here. What we will assume is, we are assuming x1 and x2 will be of this type, equal to A1, A2, yeah, and then it will be sine omega t. X1 and x2 both, we are assuming both will have different amplitude, however a common natural frequency. Yeah. This we just want to test whether it's correct, and if it is correct, then what is the condition we get? Okay. This is the same way as when you were studying the 1 degree of freedom system, you assumed x equal to a sine omega t, and then we found out what is the meaning of omega or what is the meaning of a, right? Similar thing here also, we want to find out what is the meaning of that. If there are two natural frequencies, we will get two of them. The equation itself will tell us no, there is not a single w, there are two values of w. Yeah. So let's assume like this one. Yeah. And then if this is the case, then what we get? x1 double dot, x2 double dot, we will get equal to a1, a2, and here sine becomes cos, cos becomes sine, so minus omega square and sine omega t, that's what we get. Now put these values here, and what we get? We get this. We get m1 0 0 m2, and then we get here a1 a2 multiplied by minus omega square sine omega t, this one, plus, let's do plus here, plus, and then we have k1 plus k2 minus k2 minus k2 k2, and then we have x1 and x2, which is a1 and a2, and then we have sine omega t is equal to 0, 0. So this is what the equation we got finally. We can now combine, because what we see is sine omega t, sine omega t. Sine omega t is not always 0, so we can just remove this one because we have the 0 that side. And what do we get finally is we can combine them together. Yeah. If we combine, we get k1 plus k2 minus m1 omega square. Yeah. So k1 k2 minus m1 omega square minus k2 here minus k2 here, and this is k2 minus m2 omega square. This we have combined these together. Only omega square is the extra term here, so that we have brought it inside the matrix itself, so that both the things a1 a2 sin omega t, a1 a2 sin omega t, they are common. So what and sin omega t we have removed. Okay, so what we get finally, this is a sin omega t is a scalar term which is multiplied both the sides. We can remove easily. So what we get finally is a1 a2, and that is equal to 0. So this is the matrix. We have all linear equations, two linear equations involving a1 and a2. a1 and a2 we have to find out, and we also have to find out omega basically. So this will give both a1 and a2. However, we have three variables and only two equations. Yeah, so we will see what we can find out, what we cannot find out. But this is the equation that we need to solve. Yeah, so let's see how we will solve this one. Okay, so we have this equation that we want to solve. Okay, this equation is homogeneous, meaning that on the other side values are 0. Okay. Okay. Now when a1 and a2 are non-trivial, so non-trivial meaning that a1 not equal to 0, a2 not equal to 0. One solution is simply a1 equal to 0, a2 equal to 0, you get 0. But that's not the solution we are looking for. So the other solution we can do, like when you have, let us say, a matrix M, okay, and then you have, let us say, x1, x2, or in this case, let's call it this matrix, let's call it matrix B, big B, and here you have a1 and a2 and equal to 0. Now the solution you can find is a1, a2 equal to B inverse 0, 0, right? Will be 0 if B inverse exists, right? Means B inverse has non-zero value, right? Or some value at all, right? Okay, non-zero, non-infinity value. So has value. I will say just have value. Okay. Even 0 will do, no problem. But it should not be like infinite, for example, right? Okay. Now a1, a2 equal to this equal to 0. If you can also say if this exists in this case, or determinant, you can also write it as determinant of B not equal to 0. Yeah. B inverse exists if B inverse exists, and B inverse exists if determinant of B is not equal to 0. Right? As you know that in denominator determinant of B will appear. If determinant of B is non-zero, automatically this will be a non-zero is non-zero, automatically this will be a some value, and that if you multiply by 0, automatically it will be 0. Okay. Now, if we are saying that A1 and A2 are non-trivial, and in that case, what we are looking for is, if A1, A2 are non-trivial, then does not exist. Means it's difficult. This will be like infinity, all terms in infinity, something like that. That exists. That really means what is determinant of B has to be equal to 0. So if A1 and A2 are non-zero, then determinant of B has to be 0. Okay, this is not new. This you must have studied already in your linear algebra class, in the matrix algebra class. Yeah, you must have probably in first year. Yeah? So same strategy we will apply. In this case, what the B matrix is, in this case, this is the B matrix, right? So that means B matrix multiplied by this A vector A1 A2 equal to 0. If that is the case, if A1 and A2 have, definitely it has some value, that means determinant of that has to be 0. Then only it's possible, otherwise it's not. Okay, so that really means we are going to actually find a determinant of that. Okay, so that tells us determinant of, or simply we will use like this, K1 plus K2 minus M1 omega square minus K2 minus K2 minus M2 omega square is equal to 0. And from here we will get the value of omega. And then you can solve. Assume omega square equal to lambda, also known as eigenvalue. Right? Finally, it is if you divide by, okay, we will find out later. But let's but this is lambda. Typically, we call it eigenvalue. This becomes a kind of, this is the eigenvalue problem. Okay, so we will get the eigenvalues. So in matrix, the eigenvalue of matrix, like in the solid mechanics, we have seen, like you have the stress matrix, yeah, and the eigenvalue of the stress matrix, you have the principal stresses, yeah. So similarly here, the eigenvalue of this matrix actually gives you the natural frequency. Okay, so okay, now how to find out? Okay, the determinant of that, you are putting omega square equal to lambda, so we can find out K1 plus K2 minus M1 lambda multiplied by K2 minus M2 lambda minus K2 square is equal to 0. Yeah, or simply we get K1 times K2 minus M2 lambda K1, okay, plus K2 square minus M2 lambda K2 minus M1 lambda K2 plus M1 M2 lambda square minus K2 square equal to 0, or we have K2 square, T square here. So we can write in terms of lambda. So we have M1 M2 lambda square. So this is done. Okay, then we write the lambda term. So we have M2 here, M1, okay, so minus, and we have M2 K1, M2 K1, M2 K2 minus plus M2 K2 plus M1 K2, this term lambda, so this term all negative, so captured here, and then plus K1 K2 is equal to 0. So what you see here, this equation is a quadratic equation. You can find out lambda 1 and lambda 2. You can find out lambda 1, lambda 2 equal to r. So that will give you the two natural frequencies omega 1, omega 2, where lambda 1 is equal to omega 1 square, lambda 2 equal to omega 2 square. Yeah. So you solve this equation, you will find out lambda 1, lambda 2. This lambda and lambda 2 actually are the square of the two natural frequency that we talked about in the beginning. Okay, so this is how you get the natural frequency. This equation will give you the determinant of this. You solve, you get the natural frequency. Okay, now we have got omega 1, omega 2. The next thing is finding out A1 and A2. Omega we know already. Okay, and what is A1 and A2 now? So A1, A2 equal to what? That we have to find out. Again, remember that if this is eigenvalue, initial frequency eigenvalue, what should this be? Okay. For every eigenvalue lambda, there is an eigenvector which comes here. So if this is eigenvalue omega square, this is the eigenvector. So corresponding eigenvector as the value of A1 and A2. Okay, so A1, A2 are eigenvectors corresponding to the eigenvalue lambda equal to omega square. Right? So there are two, so hence you will get two values, two sets of A1 and A2. Right? So what will you do? You solve this one, find out what is omega 1, omega 2. So you take one omega 1, you put it here, and then now you solve for A1 and A2. There will be two equations in A1 and A2. You solve for it, and you will find out the value of A1 and A2. Okay? You will get from this equation only, the value of A1 and A2 you get from this equation only. You have solved for omega 1, omega which has two values, take one value at a time, put omega 1 here, and then you multiply now these to A1, these to A2, then this to A1, this to A2. Now solve for A1 and A2. There are two equations in A1 and A2. Okay. However, they are also dependent basically, meaning that you will not get the unique equation, unique value of A1 and A2. Yeah. So, but in any case, you will get the ratio of A1 and A2. You can find out from here, and you can do it. Yeah. So the eigenvector corresponding to the eigenvalue. So you can say like this, A1, A2, and you can say 1 and 2 like this, meaning that, 1 here, meaning that this is corresponds to the first eigenvector, eigenvalue, A1, A2, corresponding to lambda 1. Say lambda 1 equal to omega 1 square. Right? So, and similarly you put 2 here, so A1 2, A2 2, corresponding to lambda 2 equal to omega 2 square. Yeah, so you get two sets of eigenvalue and eigenvectors. Eigenvalue is natural frequency square, eigenvector is A1 and A2 we are talking about, means the ratio of x1 and x2 in both the, means alpha and beta you can find out from there. The ratio of ratio of A2 to A1 is either alpha 1, alpha or beta that we were talking about in the beginning. So that's how you can find out from here. So given these equations, this one we can find out the value of lambda, or we can say omega square equal to lambda is equal to m2 k1 plus m2 k2 plus m1 k2. So this is minus b plus minus root a square, and then this one m2 k1 plus m2 k2 plus m1 k2 square. So b, so minus b plus minus root b square minus 4ac. So we have minus 4, then m1 m2 and then k1 k2. Okay, so minus b plus minus root b square minus 4ac divided by 2a. So you have 2 m1 m2. Yeah. So you can see now the omega has k over m form. So for example, this is the m1 m2 times k1. So m2 cancels out, you have k1 over m1 form. So omega, this lambda does have like omega square in form of omega square, right? So unit is matching basically, that's what I meant to say. Okay, so for your real problem, value of m1 k1 m2 k2 are known, hence you can find out the value of lambda, right? So one value plus will give you lambda. Okay, so this gives you lambda and lambda 2. So plus value, let's call it lambda 1 value, this minus value will be lambda 2 values. Hence there are two values of lambda 1 and lambda 2. Here we assume that lambda 1 and lambda 2 is known now. So what we know is lambda 1 equal to omega 1 square and lambda 2 equal to omega 2 square. Both are known. We are going to find out. We are going to assume now. And how known? You can find out from here. So no use of this equation now. We can erase this one. Now this equation we have to find out A1 and A2. Now the thing is, we have two equations, two value of lambda 1 and lambda 2. The first we will put lambda 1. So take lambda 1 first. Take lambda 1 first. Okay. And then what do we get? Okay, so we get k1 plus k2 minus m1 lambda 1 minus k2, here minus k2, k2 minus m2 omega square. So we have this, yeah, and then we have a1, a2, and this is equal to 0. So this is the equation we have, yeah, and we have to find out the solution. Okay, and how to find out? Just we will show for lambda 1 only, and similarly you can repeat for lambda 2, you can find out the value. Okay, so this is no use here. So what will you do next? Next it will be just to find out two equations now, right? So two equations will be k1 plus k2 minus m1 lambda 1 times a1 minus k2 a2 equal to 0, right? Okay, and the second equation becomes minus k2 a1 minus k2 a1 plus k2 minus m2 lambda 1 multiplied by a2 equal to 0. Okay, so we have these two equations. However, since, okay, remember, since determinant is 0, both the rows, one row can be expressed as a multiple of the other row, because that means both are dependent, and that's why determinant is 0 to begin with, right? So determinant is 0 when two rows or two columns are same, then determinant becomes 0. So in this case also, the two rows both are basically the same, and that really means that either you can take this or that and you can find out the same solution. In fact, you can put whatever value of lambda 1 and lambda 2, lambda 1 you got, you put lambda 1 here, lambda 1 here, you will see that both equations become the same, meaning that if you find out a1 over a2 from here, same ratio you can find out with this equation also, because both are dependent. So you will say this is dependent equation. Dependent equations. Okay. So simply from here we can say that a1 over a2. Okay, let's write in terms of a2 over a1. That's what I wrote. So a1. So a2 over a1. Okay? So a2 over a1 will be simply is equal to k1 plus k2 minus m1 lambda 1 divided by k2. Now, since this is for mode 1, meaning that the natural frequency 1, hence we will write like this one here, so that because there will be two such values, and we call this one is equal to alpha. Okay, so just to relate with the initial discussion, so we call this one alpha. Yeah, so a2 over a1, this value you can find out from there. So from here what you have, k1 is known, k2 is known, then lambda 1, that's known. So you get alpha, you can find out from here. Yeah, okay. Now what? Similarly, you can do for repeat for lambda equal to lambda 2 or omega equal to omega 2 square, and then you will get, similarly you will get a2 over a1, this is 2, second mode, okay, equal to, you get k1 plus k2 minus m1 lambda 2 divided by k2 you will get. Okay, so you will have lambda 2 here and lambda 1, yeah, and this we call it minus beta. Okay, we assume there minus, okay, because just to show that the mode shapes will be the one going down, the other will be going up basically, but we don't know which equation is actually will give us that mode, whether it is lambda 1 or lambda 2, hence we don't know. So whatever the absolute those ratio that we assume, we just put it here, or we can say this was the lambda 1, okay, equal to lambda, okay, and this one is equal to minus beta, or you can say equal to lambda 1, this is equal to equal to alpha 1, this is alpha 2. That represents the ratio basically, that's what I mean to say. So once we have that, okay, then we can write the equation now, okay? And the equation will be that you get two of them, you can write it as, the equation will be, okay, so we have, so far what we have lambda, we have alpha known, alpha which is alpha 1 equal to alpha and alpha 2 equal to minus beta. We have these values now, so the idea is to write out the equations. Let's write out that. So equation will be, we can write it as x1 x2 is equal to, of course there will be a combination of the two system, yeah, so hence we will have c1, then we have a2 over a1, so if a1 is 1, a2 is alpha, so we have, or alpha, let's call it alpha 1, so c1 1 over alpha 1 equal to alpha only. Okay, and then what we said, we had sine omega, in this case omega 1t, we have to write omega 1t, or root lambda. Lambda will be a positive number. Okay, so we have omega 1t, and plus we will have c2, and then what will have alpha 2, so 1 alpha 2. Okay, and then we have sine omega 2t. Okay, so this is the solution we get. But I said there are 4 equations, like 4 initial conditions, right? 4 initial conditions means x1 t 0 equal to 0, x1 dot 1 0 equal to 0, x2 0 equal to 0, x2 dot equal to 0. There are 4 equations. Here looks like we know alpha 1, alpha 2 already, omega 1, omega 2 we know already. We know the number, numerical value. Only remains is c1 equal to what, c2 equal to what. We have 4 equations here, only 2 unknowns. Where are the other unknowns? That's the thing. Okay. You can guess it. Basically, where is the phase angle? Meaning that there will be combination of the 2 solutions, but there may be phase difference between the 2 solutions as well. Meaning that, let us say the spring mass system, this is K1, M1, K2, M2. So you have started first mode, both going down and up simultaneously. Okay? And they are here somewhere at some phase. Then you have also added the second mode. Yeah? The phase, there will be phase difference between the 2. And then what will you do? Accordingly, they have to add it together, right? So actual solution, complete solution will be like this: x1, x2, and then you have c1, 1 alpha sine omega 1t plus phi 1 or psi 1, whatever you can have that, plus c2 alpha 1 over alpha 2, 1 alpha 2 sine omega 2t plus phi 2. So this is the complete solution now. We can have these values entered here, yeah, and we can find out the value of phi 1, phi 2, and then value of c1, c2. All you can find out if you have these initial conditions. So this represents the complete solution of this 2-degree of freedom system. Okay, so that is all for this lecture. We'll talk in details in next one.